Today's lesson is going to review Pythagorean theorem and tangent ratio. Recall that Pythagorean theorem is a formula that works for right triangles. And here is Pythagorean theorem right there. And one of the key ideas with Pythagorean theorem is there's a relationship between the length of the sides and the hypotenuse in this manner. It's important for you to remember that the hypotenuse is always the longest side and it's always opposite the right angle. And past that, all we need to be able to do is to apply Pythagorean theorem to find an unknown side. So we'll do two quick examples to remind you how to apply Pythagorean theorem. So in this question right here, we want to find how long the hypotenuse is. And remember, the hypotenuse is the longest side. It's always a good way to check your answer. So 3.9 centimeters is the longest side of the legs of the triangle. So I know the hypotenuse has to be longer. So there's always a good habit to write down the formula, and then we can just plug in the numbers and follow the steps. So 2.5 squared plus 3.9 squared is equal to c squared. Our next step is we want to expand out those numbers and then add them together. Now you could do this all on your calculator, but I'm going to actually figure out what 2.5 squared is and 3.9 squared, and then I'm going to add them together. And here's where we are. We're almost finished. But the only problem now is we want c, not c squared. So again, remember from grade 8 and 9, you take care of a square with a square root, and what you do to one side, you do the other side. So when we take the square root of both sides, again, just pushing a button on our calculator and rounding to one decimal, we get 4.6 centimeters, which makes sense because it's longer than 3.9. So when we are asked to find the hypotenuse, we plug the numbers in, we add those two numbers together, and we take the square root. Well, when you want to find an unknown side, it's just a little bit trickier. But again, we have a right triangle and we have two of the sides, so we start off with our formula and then we plug it into the appropriate place. So little a is the side opposite big A. And it's a good habit to get into, so that's that. The b we don't know, and the hypotenuse we do know. So again, it's important for us to recall the hypotenuse is the longest side. So when we do our calculation, whatever we think b is, it has to be less than 7.4. And that's a way to make sure you haven't made a mistake. So again, we'll get in the habit, first of all, of expanding out these squared terms just to get plain old numbers. And then in this case right here, this is where it's different from the example above because the numbers aren't together. So what we ultimately want to do is we want to get b by itself. So we have to move the 12.96. And the way we move 12.96, again from our grade 8, grade 9 equation solving, is we add the opposite. And when we do that, we end up with the letter by itself, and we want b not b squared, so we get rid of the square with the square root. And when we take the square root of both sides, we get 6.5, which is less than 7.4, so my answer makes sense. So that's all we need to know about Pythagorean theorem to help us in this unit. The other thing we need to remember is a little bit of trigonometry from grade 10. if we use this triangle to the right, and the idea of slope is rise over run from the last section we did, relative to angle x, this is the vertical part, and that would be the rise, and relative to angle x in this triangle, or the hypotenuse, that would be the run. So we can use a slope relationship to determine the steepness of the hypotenuse, and if we could also look at it in a different way. We can look at it as simply an angle. So in this one, slope is rise over run, and in my triangle here, that's x over y. But I want you to recall that with trigonometry, the tangent ratio is opposite over adjacent, and relative to angle x, that is the same as slope. So another way to express slope is as a tangent ratio, and if we have the tangent ratio, we can actually express slope as an angle. And when we're talking about slope in this way, angle x is referred to as the angle of elevation. So last lesson, we learned that slope can be expressed as a fraction or a decimal, and we're adding today, slope can be expressed as an angle of elevation. So here's one quick example. Determine the slope of the hypotenuse as a fraction and as an angle. So again, here's our hypotenuse right here. I'll just call it C. And the slope of that hypotenuse is equal to rise over run, which is it goes up 6.8 as it goes over 4.2. Now, technically, we don't want decimals and fractions. So if we multiply the top by 10 and we multiply the bottom by 10, we have an equivalent statement and no decimals. And in fact, if we wanted to simplify this by eliminating a common factor, the biggest number that goes into both those numbers is 2. So the slope of that hypotenuse is 34 over 21. If we wanted to figure out the slope as a measure of the angle of elevation, if we wanted to express slope that way, then we can use the tangent ratio. And the tangent of angle theta is equal to opposite over adjacent. Now, the great thing about this, and we learned this in our grade 10 trigonometry unit, we don't care about decimals. We're pushing buttons on a calculator. So recall that in grade 10, in order to find an angle, that's when you pressed this button, the inverse tangent, or just think of it as a button on our calculator. So in order to figure out the angle of elevation, we're going to press this button on our calculator, and we're simply going to punch in this relationship. And remember, always close your brackets. If your calculator opens brackets, close them. And when you hit the enter button, your calculator will spit out 58.3 degrees. That is the angle of elevation that expresses this slope or this slope or this slope as an angle.